Hello friends, today's question. A ball of mass 0.5 kg is attached to the end of string having length 0.5 meter. The ball is rotated on a horizontal circular path like a physical pendulum about a vertical axis. The maximum tension that the string can bear is 324 Newton. The maximum possible value of angular velocity of the ball is. So this is a ball of mass m connected to the string whose length is given as L and it is 0.5 meter, and it is being, you can say, rotated about the circular path. So in this case, let us draw the diagram with all the forces. So we have a ball of mass m. In the vertical downward direction there will be mg, and we have tension T. This tension T can be divided into two components, and this is given as theta. This is theta, so we get T cos of theta, and this will be T sin of theta, and it is being rotated in a circular path. And let us suppose the radius of which is given as r. Therefore, we can write the equation for the various forces that will be acting on it. So first of all, in the horizontal direction, this is mass m. Forces acting on ball of mass m first is in vertical direction. So vertical direction, we have two forces, mg in the downward direction and upward is T cos of theta. You can say T cos of theta is equal to mg. That is called equation number 1. And in horizontal direction, there will be T sin of theta, which is going to provide the centripetal force. You can say T sin of theta will be equal to centripetal force, and this will be coming equal to as mr omega square, where omega is angular velocity, which we are supposed to find out, and length is given as L. This is length L. So we can find out that where r is equal to L sin of theta. R is equal to L sin of theta. So if we substitute here value of r, we get T sin of theta is equal to m multiplied by L sin of theta and omega square, and sin theta goes away, so we get T is equal to ml omega square. So from here we can say that our angular velocity omega is equal to T upon ml its square root, and the tension is maximum. So we can say at maximum tension Tmax W is equal to Wmax. So we modify this equation, we get omega max is equal to square root of Tmax divided by mass into length L. Substitute value, maximum is given as 3 to 4 and mass is 0.5 multiplied by 0.5. So we get our maximum angular frequency, angular velocity will be coming equal to as, this will be 36 radian per second. We can say this is the maximum possible. This is maximum possible angular velocity. So this completes the question. Thank you.